Hello students, in today's video we're going to talk about rates of change and limits. But before we do that, let's do a quick warm-up. Please simplify both of these problems. This would be a great time for you to pause your screen and try solving it on your own. Hopefully you've paused your screen and you're now just checking your answers. So for both of these, you'll notice that we want to simplify. And for the majority of these problems, we want to start with factoring at all times. So first we notice x squared minus 4. Now that's a difference of two squares. So we're going to go ahead and type out x plus 2, x minus 2, all divided by x minus 2. And you'll notice because we have the same binomial on the numerator and denominator, they cancel out, and we're left with x plus 2. We'll go ahead and do the same thing for part B. This turns out to be x plus 4 times x minus 1. And the bottom is a difference of two squares as well, so x plus 1, x minus 1. And again, we cancel out, and we're left with x plus 4, all divided by x plus 1. So, when we talk about limits, we want to look at what limits are. And these are things that you see in your everyday life. So when we talk about the speed limit of a car, our car is going to approach our specific speed limit. Same thing in math. Now, by definition, the limit is the y value that a function approaches as x approaches some given value. And typically it's written in the following limit notation. The way we read it is the limit as x approaches a for f of x, or as of f of x equals L. Now, L is supposedly the limit that we're approaching. So as x gets closer to, but remains unequal to a, the corresponding values of f of x get closer to this limit. So let's look at a more specific problem that should help make this easier. So in example 1, we're going to use a table. And we have the function, the limit as x approaches 2 for x squared minus 4, all divided by x minus 2. You'll also notice that we have a table of x values and of y values. The x values, you'll notice, they're all on both sides of the 2, which is why we have this blank in the center. And what I use is I like to use an app or a website called Desmos. Now Desmos will allow us to input this graph and create a table. So if you'll notice, I put in the same values, 1.9, 1 and 99 hundredths. And if you look at only the y values, you'll notice that as our y gets closer and closer to 2, our y values get closer and closer to 4. Unfortunately, when we get to 2, it's undefined, but that's not for us to worry about right now. As we get just past 2, it's still just above 4. So for this particular example, the limit as x approaches 2 would be equal to 2, even though at 2 it's undefined. So now we want you to try using a table for the following graph. You're more than welcome to use a calculator. Hopefully you've done that and we're coming back to check this value. Now again, we've taken the same process out of the first example and we've done it here. It's approaching 0, so we want all of our values to be surrounding 0, which we did here. Now you'll notice that as x approaches 0 from both sides, they get closer and closer to 1, but when it becomes 0, it's undefined. Now, let's talk about one-sided and two-sided limits. We have a right-hand limit, and this says to look at the graph as x approaches from the right side, or from the positive side. Hence, the limit as x approaches c from the positive sign for f of x. A left-hand limit is as x approaches from the left-hand side, or from the negative side. So the positive and the negative tell you which side they're coming from. Positive means from the positive or the right, and negative from the negative side or the left. Now, it's important to mention that the overall or two-sided limits exist only if the right and left-hand limits are equal. So to simplify that, it means we only have a limit, an overall limit for a function, if the left side and the right side approach the same value. So let's take a look at this example to make this a little bit more clear. Now, for part A, it says find the limit as x approaches -1 for f of x. So let's put a point at -1. Now you'll notice from the left side, it's approaching -1, but it actually stops right at the y value for 1. When we come in from the right side, it's approaching 2, or the y value is at 2. So therefore the limit here at -1 does not exist. Now let's take a look at part B. Part B says to find the limit as x approaches 0 for the function. So let's take a look at that now. As x approaches 0, from the left side, the y value is 2. When x approaches 0 from the right side, the y value is also 2. So for part B, the answer should be 2. For part C, the limit as x approaches 1, let's change this color. So as x approaches 1, notice that there's an open circle there. That means it doesn't exist. But when it's really close to 1, the y value is 2. When we approach from the right side, the y value still is approaching 2. Therefore, the answer to part C is 2. Finally, let's take a look at part D. Part D says the limit as x approaches 2 for f of x. So as x is approaching 2, from the left side, you'll notice that the y value is getting towards 3. As x is approaching 2 from the positive side, you'll notice that it continues to go down towards -infinity. So because they're not the same exact number, part D does not have a limit, so D and E. So let's take a look at your U-try. Now, what I'd like for you to do as a quick assignment is write down any questions that you may have and be ready to share that with the class tomorrow. Tomorrow we're going to do some practice, so that's all for now. I'll see you guys next time.